Just see that what is the result of del cross F. We know that in between two vectors A and B, we can define A dot B as the dot product or scalar product, as well as A cross B, which is called or termed as vector product. So, here also del is an operator and F is a vector point function, and in vector calculus we define del cross F as curl of F, which is very important, similar as divergence of F. This has deep physical application, both divergence as well as curl of a vector point function. So, what is del? We should remember that del is nothing but this vector I del del x, j del del y and k del del z. For our advantage, we have shortened this notation. Del del x is written as del suffix x, del del y is written as del suffix y, and del del z is written as del suffix z. So, what is curl cross F? Curl is this vector and F is this vector. So, obviously, according to the definition of cross product, we can write I cap, j cap, k cap, and then the component of del with I cap, which is del x, then component of j in del, which is delta y or del del z. This is actually del del x, this is actually del del y, and this is actually del del z. And then we write the components of f as I cap, j cap, and k cap. Similarly, in the first column, we write the component of I cap, which is 2 x y z plus y square z plus y z square. Then the component of del y, which is, let us write it clearly with proper positioning, so that distinctly. So, this is the first component of f, and the second component of f is, here it is del del y. So, we write it as 2 x y z, the second component as x square z plus x z square, and then the third component becomes x y square plus x square y plus 2 x y z. So, this determinant gives us the value of this del cross f, which is known as curl of f. Okay. We write I cap, j cap, k cap and the components of del, del del x, del del y, del del z in first column, second column and third column, and then the component of f, this and this in first column, second column and third column. And when we calculate this determinant out, it will be more or less easy to write, because del del y of this term gives us 2 x y, 2 x z plus x square, is not it so? Just see, del del y of this gives us 2 x y plus x square plus 2 x z minus del del z of this function, which gives us minus 2 x y minus x square minus 2 x z, is not it so? So, I cap has component del del y of this function, which is x y square. When we take the partial derivative with respect to y gives 2 x y, x square y with respect to y gives x square, and 2 x y z with respect to y gives 2 x z, minus of this into this. So, del del z is operator on this, is operator. So, this will be operator on this. Mind that del del y will be operator on this and del del z will be operator on this, because the order is this when we expand this determinant. So, what is del del z of this? It is nothing but 2 x y, then x square and then 2 x z. So, this 2 x y and 2 x y cancels out, and then x square and x square cancels out, and then 2 x z cancels out, and this becomes 0. So, I cap component is 0. we can calculate the j cap component now. So, what will be the j cap component? It can easily be shown to be 0, because when you can calculate the j cap component, we skip this column and this row. So, it will comes out to be del del z of this minus del del x of this. We know that this is the 1 2 element which is odd. So, actually it will bear a minus sign, and to adjust it we reverse the order of the multiplication. So, del del z of this gives us 2 x y plus y square plus 2 y z, while del del x of this gives us minus of del del x of this gives us minus y square, x y square, del del x gives us y square, this gives us 2 x y, and this gives us 2 x, sorry 2 y z. Just see del del x of this x y square gives y square, x square y gives 2 x y, because x square del del x of x square is 2 x, y is constant, and what about 2 x y z? Y z is constant. So, del del x of x is 1, and this comes out to be 2 y z, and here also we have 0, because all the terms cancels out. And it is apparent, you all know from the symmetry, that the k component will also have 0 value. You can check it. I claim that k cap will be 0 because of symmetry and nothing else. You can check it out, because the k cap component is, you skip this and this. So, del del x of this minus del del y of this, which is obviously 0, you can check it out. So, we have curl f as 0, and you should remember that whenever curl of a vector function is 0, we call that vector as irrotational. Irrotational. We call that function to be irrotational. F is irrotational, and that is all. Okay.